This is a really quick tutorial on how to use the software OriginPro, this is Model 8, to make publication quality plots or graphs rather than using Excel for lab data of any type. Here I have some example data. This is cyclic voltammetry data, electrochemical data. I've already pasted this in from Excel. I'm not showing you the front end of that because it's different depending on the instrument, but generally you'd export your data as either a text file or CSV. I like to then import it into Excel first and then just clean it up there. So delete any headers or labels. Usually there's a whole bunch of lines at the top of your data that you don't need. So I delete all of that, clean it up, make sure I have really nice XY data. And then I just copy it from Excel and paste it directly into these two columns, which are here for default. First thing I'll show you is often you'll want to transform these data, maybe multiply it or divide it by some factor to change, say, the units of a particular axis. And that's always the case for cyclic voltammetry. The data comes in units amps, but we almost always plot this in milliamps. And so to do that, you could have done that in Excel if you're comfortable doing that. You can also do it here. I need to add a column. So this isn't like Excel where you have an infinite number of spreadsheet entries. You come default with just X and Y. And if you want to add more columns, you need to do that explicitly. And to do that, you'll click this Add New Columns, or you can right click, and then choose Insert. I'll just choose this column here. You can see that gives me C. Notice also that we have explicit labels of X and Y. So those aren't random. We want whatever data we want on the X-axis to live with an X label right here. And similarly, we want anything on the Y-axis to have a Y label. Notice that if I create new columns, they'll default as the Y. And if I wanted to change how I denote either of these columns of data as X or Y, I would just right click on this and then go down to Set As. And here you can see it's already labeled as Y, but I could choose this as an X. I could choose this as a Z if I'm making a three-dimensional plot. I could choose this as a label if I'm using this column of data to add some sort of categorical label associated with each of those rows. I could choose not to include this in any data, or I could label these as either the X or Y error components that would go into creating some sort of error boxes or error bars. So in this case, for voltammetry data, we almost never plot in amps. And so if I wanted to plot this in milliamps, which is more common in the literature, I would put my units, label this. I'm going to put current here. And actually, I have these labeled. I'm just going to delete these so that it's clear. You can add comments if you like about that data, the source of that data, or what it means. That doesn't get included in the graph. It's just there for your own reference in the future. So if I wanted to convert my B column to milliamps, I'm multiplying that by factor 1,000. So I'm going to right click. I'm going to choose Set As. I'm going to choose Set Column Values. This allows me to type in a formula. So I'll put column C equals column B times 1,000, and then choose Apply, and you can see that updates accordingly. So you can type in more complicated formulas here. It's not unlike what you would use in Excel. You can use the formula drop down, you can save things. I tend to not do much transformations other than simple ones like these because I'm more accustomed to using Excel to do more complicated formulas, but it's up to you. So I'll choose OK. All right, so this is holding a Y variable, this is holding an X variable. If I want to make a graph of these two things, then I could click this and then hold Control and click my Y data. Otherwise, I could plot these two together. And so I'm going to click these two and make a plot. So to make this plot, I can do a couple different things. I can either use these hotkeys way down here at the bottom if you have those and you see those. These are different menus of different types or categories of plots. So these are these line plots. If you click the drop down arrow, you can see various types. These are scatter types. I can do it with errors, I can do it with drop lines or bubbles, color maps. These are the connected scatters, just like Excel would have, various bar and pie. These are if you're using two different y-axes, or if you're making paneled versions or waterfall or stacked versions of data. All these are very useful visualizations. Here are histograms and box and whisker plots. These are various area filled things, etc. We tend to use most commonly scatter data or line data for typical plots in the lab. So those are the sort of quick keys. Otherwise I can go up to plot. You can see these same groupings but in a textual representation. I can see my lines, my symbols, my line connecting symbols, etc. So in this case I'm going to do a plot and a line and choose my line option, and that's going to generate my line plot for me. And this is the sort of default raw output that I'm going to get. And so you'll notice that it's labeling my current and my units, or I'm sorry, my axis label and my units and my axis label and my units according to what I had put into those categories back in my book. And so also notice this sort of navigation space over here. And so organizationally, it's quite different than Excel, where you have a single file, but you have some tabs. Here I can create whole folders of workspaces with various sheets and graphs that are associated with those sheets. And so right now I'm under folder 1, that's the default, under this untitled branched folder. And then book 1 was where I had my original data, so I can double click that, that'll pull up my original data. And now the graph 1 is the graph associated with that. And I can go here and I can rename these and I can put CV data. And I can go to my graph and I can rename this and I can say this is CV at 25 millivolts per second. And I can make various graphs according to these data. Okay, so let's play around with these data. So how do I want to plot this? Well, all right, there's some aesthetic choices that I'll point you towards so that we have a standard set of figure conditions, so they all look the same for papers. And then there's some specific changes that we'd need to make for plotting cyclic voltammetry. And so we, in my lab, tend to produce voltammetry data under what's called the Texas convention. And in that case, reducing current where electrons are flowing from the electrode into the solution, that is positive current, so greater than 0, and oxidations are negative current. And so the data we have here is plotted correctly in that format. This is reducing current, this is oxidation current. What's different here, what we need to change, is that in Texas convention, negative values or more negative potentials are plotted going towards the right and more positive potentials are plotted going towards the left. So let's look at how we might change this. So I can click on my axis, I can double click this axis, and that pulls up my x-axis for the layer that I'm plotting here. And so if I look at these options, we're going to go through a bunch of these. What I want to go to first is scale. And so the scale is telling me that I want, or that my horizontal axis is being plotted from -1.9, which is this tick here, out to 0 here. And so I can just choose 0 to -1.9, and that should just flip the axes of my data. So I'll apply that. And now you can see I'm plotting in the correct convention. So more positive values here, more negative values here, and I didn't do anything with my current axis, so all is good there. Notice that I can change the increment here, so if this looks a little too dense to me, I could change this to 0.5, for example. and click apply. And we get more space between those lines. Okay, so let's think about more aesthetic choices now that we have the format of the graph at least plotting in the right convention. So what I like to do in my lab to make all of our figures look the same is to start with title and format here. And you can see each of these red bars tells you which line of the overall graph you're plotting. And so we like to have all 4 sides of the graph showing in bold 5-point thickness. So at the bottom, I'm going to choose show axis, which is default because you can see it's here. And I'm going to choose 5. And then instead of the major ticks going outward, we want those to go inward for both the major and the minor ticks. And you can choose apply and you'll see what that looks like. So that'll bolden that up and move the ticks inward. Similarly, I'm going to show my top, and I'm going to make that 5, but I'm not going to show, typically, unless you really feel like you need ticks at the top, but we generally don't show any ticks on the top. On the left side, we're going to bump that up to 5. We're going to move those to in. And on the right side, we're going to show those, make them 5, and leave those as none. I'll click apply and you'll see this whole thing get more bold. Okay, next thing we want to do is go to the tick labels. So tick labels are how we're labeling each of the ticks. Right now we have labels just on the left and the bottom, which is what we want to preserve unless you had a second y-axis or a second x-axis. So we'll go to the bottom first. We typically use a font size of 36, and I'm going to click apply. You can see that's why I spaced those out more. If there were too many ticks, these would start to overlap, and then you'd need to go back to scale and change your increment accordingly. So I'm going to leave that at 36. I'm going to keep my leftmost tick labels as also 36, and we'll see if they get too crowded. Nope, that seems pretty reasonable. So I'll leave that. I don't bold those, I just leave them like this. All right, great. We tend to occasionally use labels if I'm using overlays. If I'm using a single line, then I don't need to do that. So I would just click delete there. If I had multiple overlays, then I would want to label each one accordingly. All right, so what we need to scale up our font size. Notice if I double click this, it gives me this %Y. That's telling me take the name of this axis from this spreadsheet where I have it labeled here, current and milliamp. You can keep that if you'd like. I tend to just repurpose this and write it out myself. And then I'm going to bump this up to 44 typically, somewhere in that range, and bold it. And it looks something like that. Similarly, I'm going to do potential, and then I'll put bolts versus silver chloride like that. I will bold this, and then I'm going to pop this up to 44. All right, so that looks pretty good so far. Next, we need to make our line of our graph match the boldness of the rest of the figure. And I'm going to just double click right on that line. And now I get line edit options. And notice right now it's at the smallest, 0.5. I'm going to bump it all the way up to 5. I can choose different colors here if that's important. For instance, if I wanted to use blue, I could do that. And then click OK, and now we have this graph. Okay, so these are the basic tools of setting up this plotting. Notice that the bottom edge of this label is getting a little cut off here. The white screen that you see here, this is the copyable image of the photo of the figure that would get pasted into, say, a manuscript. If it's cut off here, it's going to be cut off. There's no scrolling in this. So we need the figure to fit there. And so in order to do that, we can just click on the figure and just move it up. I'm just using the arrow keys here, and notice I'm just shifting this up into the frame. And it looks something like that.